Okay, this is the M1 June 2015 question number 6, and this is on accelerated motion. Okay, so it says a bus travels along a straight horizontal road. It leaves bus stop A starting from rest and accelerates at a constant rate for 10 seconds until it reaches a speed of 20. Continues to travel at this constant speed for t seconds until it stops accelerating at point B. Draw a velocity time graph for the motion between A and B. So I'm going to start by doing that one. Part A. And it doesn't have to be completely accurate, just needs to be a sketch because they've said the word sketch. So we're going to have velocity up the side and time along this side. Okay. Now then, it leaves bus stop A starting from rest. I'm going to highlight the keywords in this one here. And then it accelerates at a constant rate for 10 seconds. So we know it's leaving from rest and it's going to accelerate for 10 seconds. So we're going to show it like that. Remember, the line shows acceleration. And that's for 10 seconds. So we can put along the line here. T is in seconds, so we're putting 10. It reaches a speed of 20 meters per second to the -1. So up here, it's reached a speed of 20. It then continues to travel at the speed, and t seconds after it stops accelerating, it passes a point B. So it continues at the speed, so it's not accelerating, it's continuing. So we're going to draw a horizontal line. And t seconds after, it passes the point B. So this part here is t seconds. So this gap here, up to here, from 10 to here, is t seconds. So we've got the 10 and the t, so it gets to be at t plus 10 or 10 plus t. And there's our velocity time graph, John. Now then, part B says, find the acceleration of the bus. So these are going to use our SUVAT equations. So first thing you should do when you're answering these is write down all the bits you know. So we've got V, U, A, S, and T. So we're starting from rest. We're trying to find the acceleration. So remember, we're looking at this part of the graph. So we're starting from rest. So U is 0, initial velocity. The final velocity is 20. Acceleration, we don't know. That's what we're trying to find. The distance, we don't know. And the time is taken was 10 seconds. We can fill that in. Now, we don't want to find S, so we cross that one out. Then we're looking at one of our SUVAT equations, which uses these 4 parts. So the only one that does that is V equals U plus AT. So we're going to put in what we've got. So V is 20, U is 0, A we don't know, and T we know is 10. So 10A is 20. So to find A, it's 20 over 10. So A is 2 meters per second to the -2 because it's acceleration. Okay, that's the answer to part B. Part C then says, determine an expression for the distance between A and B. So remember, A was at the start, B was up here. We're trying to find the distance in terms of T. Now then, when it mentions distance, this is just the area under the graph here. So all you're trying to do for C is find the area. Now if we look at this, we've got a triangle and we've got a rectangle. So area of triangle, base times height divided by 2. So the base is 10, the height is 20, and we can divide that by 2. And then we've also got this rectangle on the base of this one. The base, remember, is this gap here, which was T. And the height of this one is 20. Now it does say an expression in the question. So simplifying this, 10 times 20 is 200, divided by 2 is 100, plus 20t. Okay. Part D then says, a car leaves 5 seconds after the bus has left. It starts from rest. So 5 seconds after the rest. Starts from rest and has a constant acceleration of magnitude 2 meters per second to the -2. It overtakes the bus at point B. Find the distance. So this one is slightly different. So if we were to draw the graph of this part D, if you had a velocity time graph, this one has just got a constant acceleration. So for the bus, imagine it starting 5 seconds after. So we're going to start off at 5 and just have a constant acceleration until it reaches B. Because it's starting at 5 seconds, starting 5 seconds after the bus. So there's a different shape on the graph there. Now then, it asks you to find the distance between A and B. Okay, so if we look back at this, we're trying to find the distance between A and B there. So a distance we could do as being the area underneath the graph. We've got that already, but we only had an expression. We're actually trying to work out now an answer for that distance. So in order to do that, we need to be able to replace the t. So in order to do that, we need to use the information that we've got. And we can do that now because now we've got a graph with a constant acceleration. Okay, so if we have a look at this one, let's fill in what we've got. We've got A, U, V, S, and T. Now for this one, we know the acceleration is 2, because it says that in the question. The initial velocity for this one was 0, because it started from rest. The final velocity we don't know. The distance is what we're trying to find. And the time it takes. Now then, the time it takes for this one is going to be, instead of it being, the time on this one would be t plus 10 to B. Our graph is 5 seconds less. Takes the car 5 seconds less. So the time is going to be not 10 plus t, but 5 plus t. So it takes it 5 seconds less than it does on this graph here. Okay, so looking at this, we need to find out what t is, but we don't have v. So we can't use the v one, so we're going to use s equals ut plus a half at squared. So working this out, we don't know what s is, so we're trying to find. We've got u is 0 times by t plus a half times 2 times t squared. So working this out, this gives us 0. Then we're going to end up with half times 2 times 5.t squared. So we've got 0 here. This is just going to give us 1. And this is going to need to use FOIL. So we end up with 25 plus 10t plus t squared. So we get s equals 25 plus 10t plus t squared. So if we have a look at this now, we've now got an equation for s, which is here. This is our equation for distance, and this one is an equation for distance. So what we can go on and do there is put these two equal to each other. So we end up with 100 plus 20t equals 25 plus 10t plus t squared. Putting these two expressions equal to each other because they're both the distance, just in different forms. Then we can go and rearrange this. So move the 20t over, move the 100 over. We get t squared minus 10t minus 75 equals 0. Factorising that, we'll end up with t plus 5 and t minus 15. So to finish this off, our two values are going to be t equals -5 and t equals 15. Now then, we're going to use a t equals 15, the positive one, for a time. So plugging this back into this equation to actually work out our final answer is going to give us 100 plus 20 times 15, which gives us a final answer of 400 metres.